determine the kick height, the following formula is used: kick height equals pipe circumference minus kick circumference divided by 2. This formula will allow for the calculation of the kick height. Firstly, measure the pipe circumference, often referred to as PC. This involves measuring the circumference of the pipe or conduit where the kick will be installed. Use a flexible measuring tape to get an accurate measurement around the outside of the pipe. Ensure the tape is snug but not too tight to avoid distorting the measurement. Secondly, measure the kick circumference, often referred to as KC. This requires measuring the circumference of the conduit or pipe before it is bent to create the kick. This measurement should be taken on the straight section of the conduit that will form the kick. Again, use a flexible measuring tape for accuracy. Thirdly, subtract KC from PC. Subtract the kick circumference from the pipe circumference. This step determines the difference in circumference between the original pipe and the section that will become the kick. Fourthly, divide by 2. Divide the result obtained in the previous step by 2. This final calculation provides the approximate kick height. For example, if the pipe circumference is 20 inches and the kick circumference is 16 inches, the calculation would be kick height equals 20 inches minus 16 inches divided by 2, resulting in a kick height of 2 inches. It is important to note that this formula assumes that the kick is a 90-degree bend. The kick height obtained using this formula is an approximation and may require slight adjustments to fit properly in real-world applications. The formula does not account for material shrinkage that may occur during the bending process. This shrinkage can vary depending on the type of conduit, the bending equipment used, and the technique employed. To account for potential shrinkage, it is advisable to make a test bend on a scrap piece of conduit of the same type and size. Measure the actual kick height achieved and compare it to the calculated kick height. Adjust the formula or bending technique accordingly to compensate for any discrepancies. Accurate measurements are crucial for precise conduit bending. Use a reliable measuring tape or other measuring device that is properly calibrated. Double-check all measurements before performing calculations to minimize errors. When measuring circumference, ensure the tape is aligned perpendicular to the axis of the conduit for the most accurate reading. When bending conduit, use appropriate bending equipment that is in good working condition. Follow the manufacturer's instructions for safe and effective operation. Consider the type of conduit being bent, as different materials may require different bending techniques and equipment. For example, rigid metal conduit requires a different bending process than electrical metallic tubing. Proper lubrication can help reduce friction during bending, minimizing the risk of material damage and improving the accuracy of the bend. Apply lubricant to the inside and outside of the conduit at the bending point. Avoid overbending the conduit, as this can weaken the material and make it more susceptible to damage. Gradually increase the bending pressure until the desired angle and kick height are achieved. When making multiple bends in a single piece of conduit, plan the sequence of bends carefully to avoid interference and ensure proper alignment. Consider the order in which the bends will be made and the orientation of the conduit in the bending equipment. Account for the spacing between bends and the overall length of the conduit run. Practice makes perfect when it comes to conduit bending. Don't be afraid to experiment with different techniques and settings to find what works best for specific applications. Start with simple bends and gradually progress to more complex configurations. Seek guidance from experienced electricians or attend training courses to improve skills and knowledge. Adhere to all applicable electrical codes and safety regulations when working with conduit and electrical systems. Ensure that all work is performed by qualified personnel and that proper safety precautions are taken. Wear appropriate personal protective equipment such as safety glasses, gloves, and hearing protection. Deburr the ends of the conduit after cutting to remove any sharp edges or burrs. This will prevent damage to wires and cables when they are pulled through the conduit. Use a conduit reamer or file to smooth the cut edges. Inspect the finished bend for any signs of damage, such as cracks, kinks, or flat spots. Discard any damaged conduit and replace it with a new piece. Proper support and securement of conduit runs are essential for maintaining the integrity of the electrical system. Use appropriate conduit hangers, straps, and clamps to support the conduit at regular intervals. Follow the spacing requirements specified in the electrical code. Grounding and bonding of conduit systems are necessary to provide a safe path for fault currents. Ensure that all conduit sections are properly bonded together and connected to the grounding system. Use appropriate grounding bushings, locknuts, and bonding jumpers. Label all conduit runs clearly to identify their purpose and destination. This will facilitate maintenance and troubleshooting in the future. Use a permanent marking pen or label maker to create durable labels. Consider the environmental conditions in which the conduit will be installed. Use conduit materials and fittings that are suitable for the specific environment. For example, use galvanized steel conduit in wet or corrosive environments. Regularly inspect conduit systems for signs of damage, corrosion, or deterioration. Replace any damaged or deteriorated conduit sections promptly to prevent electrical hazards. Keep conduit runs clear of obstructions to allow for easy access and maintenance. Avoid running conduit through areas where it is likely to be damaged or exposed to extreme temperatures. Use conduit fittings that are compatible with the type and size of conduit being used. Ensure that all fittings are properly tightened and sealed to prevent moisture ingress. Avoid mixing different types of conduit materials in the same run, as this can lead to corrosion and compatibility issues. Use a conduit bender that is designed for the specific type and size of conduit being bent. Avoid using makeshift bending tools, as they can damage the conduit and create unsafe bends. When bending large diameter conduit, use a hydraulic bender to provide the necessary force and control. Plan the conduit layout carefully to minimize the number of bends required. Use straight runs of conduit whenever possible to reduce friction and installation time. Consider the accessibility of the conduit for future maintenance and modifications. Avoid running conduit in areas that are difficult to reach or where it is likely to be obstructed. Use conduit bodies and pull boxes to provide access to conduit runs for wire pulling and splicing. Locate conduit bodies and pull boxes in accessible locations. When pulling wires through a conduit, use a wire pulling lubricant to reduce friction. Avoid pulling too many wires through a single conduit, as this can overload the conduit and damage the wires. Follow the wire fill requirements specified in the electrical code. Use color-coded wires to identify different circuits and functions. This will simplify troubleshooting and maintenance in the future. Terminate all wires properly at the end of the conduit run. Use appropriate wire connectors in terminals to ensure a secure and reliable connection. Protect wires from damage during installation and maintenance. Avoid bending wires sharply or exposing them to excessive heat or moisture. Use cable ties or straps to secure wires inside conduit runs and prevent them from rubbing against the conduit walls. Regularly inspect wire connections for signs of looseness, corrosion, or damage. Tighten or replace any damaged wire connections promptly. Keep conduit runs clean and free of debris. Use a vacuum cleaner or compressed air to remove any dirt or dust that may accumulate inside the conduit. Avoid using harsh chemicals or solvents to clean conduit, as they can damage the conduit material or insulation. Follow the manufacturer's recommendations for cleaning and maintaining conduit systems. Properly dispose of any scrap conduit or wire materials. Recycle materials whenever possible to reduce environmental impact. Keep accurate records of conduit installations and modifications. Document the location of conduit runs, the types of materials used, and any special considerations or challenges encountered during installation. Regularly review and update conduit installation practices to ensure compliance with current electrical codes and safety standards. Attend continuing education courses and workshops to stay abreast of new technologies and techniques in the field of conduit bending and installation. Share knowledge and best practices with other electricians and apprentices to promote a culture of safety and excellence. By following these guidelines and best practices, electricians can ensure the safe, reliable, and efficient installation of conduit systems for a wide range of electrical applications. This information provides a thorough understanding of how to accurately calculate kick height for a 90-degree bend, while also addressing practical considerations for conduit bending and installation.